Welcome, and thank you for sparing us time to view this presentation. We are Global Process Systems, GPS, a global provider of technology-based design and build solutions and processing facilities for the upstream oil and gas industry. GPS services and equipment range from standalone small skid-mounted units for onshore early production facilities, or EPFs, through to full topsides for offshore platforms and FPSOs. These can include process separation, gas compression, water injection, power generation, control equipment, and other process facilities. Over the next few minutes, we will demonstrate the capabilities and advantages of our bespoke solution for marginal field developments using our Relocatable Offshore Production Unit, or ROPU for short. Patents are currently in progress worldwide for these innovative applications. The ROPU system uses a number of sections for the substructure, each weighing less than 120 tonnes, which avoids the use of a heavy offshore lift installation vessel. Because of the modular construction, the sections can be pre-cut, and where politically desirable, the assembly can be done in-country to maximize the local build content. Firstly, the base section is lowered to the seabed using a spreader bar and slings. The GPS sling connection is designed to self-release. This avoids the need to use divers or ROVs. The base structure has 6 pile sleeves and, depending on the design requirements, can have 3 or 4 legs. These legs extend to the surface to support the topsides. The diameter of the piles and legs varies from 36 to 48 inches, depending on the currently based water depth of 40 to 80 meters and the topside load. The substructure gives lateral support only, as the legs carry all the vertical topside loads. Next, using the installation crane, the piles are driven in with an underwater hydraulic hammer. The pile-to-sleeve connection uses an optional disposable inner sleeve, which allows reuse of the base section later. Where the base section is to be discarded after the first installation, this facility is not required. Upon removal, the piles are cut using a conventional internal cutting tool. The pile-to-sleeve connection can be by spring lock, grout, or swaging, depending on field requirements. Then, the intermediate section is installed onto the base section with a stabbing cone to guide the upper jacket's connector into the lower connection sleeve. Spring-loaded pins lock the structures together. These connections are proprietary items available from Springlock in the UK and have been used and proven on many subsea structure applications. The top section is then released from its sea fastenings and is skidded under the crane, ready for lifting. Once again, self-releasing slings are used to lift the top section onto the intermediate section, which locates and then locks the frames together. GPS engineers have used a regular geometry pattern for the framework, which allows for greater economy in design. The design also avoids frame action bending moments, and the members' loads are mainly axial. It reduces in and out of plane bending, minimizes punching shear, and also improves fatigue life. The legs are then installed. The legs are the only structural elements to pierce the waterline, which minimizes frontal areas to wave and hydrodynamic forces. The substructure terminates around 10 meters below the waterline, and this gives more than sufficient draft clearance during a float-over topsides installation. The connection between the substructure and the legs is designed to give lateral support only. Unlike other designs, this is not a fixed connection, which would transfer bending moments into the substructure. As a result, the legs carry all vertical loads directly to the piles. The GPS 3 or 4 leg pile design gives improved structural support to various topside configurations. Designed to support topsides weights from 500 to 2,000 tonnes, the structure is suitable for wellhead, accommodation and process platforms alike. The substructure geometry is such that the leg spacing is greater than the barge width used for float-over installation of the topsides. The GPS structure is considered by certifying authorities as a fixed platform with piled foundations designed for site-specific conditions. Therefore, it doesn't fall under the Mobile Offshore Drilling Unit (MODU) codes. GPS has an exclusive license with Integrated Offshore Technologies Pte Limited, Singapore, for the ROPU system in offshore process platform applications. So where can this innovative design be used? The initial design is based on 12-meter maximum storm wave height and water depths up to 80 meters. It has also been reviewed for an 85-meter water depth and 16-meter wave height case and found to be satisfactory and competitive. Depending on your ultimate specification and location, GPS can offer a fast-track delivery targeted under 14 months from design through build to installation. Designed with experience gained with existing MOPUs, the ROPU has the added benefits of flexibility, lower environmental impact, and the ability to maximize local input in final construction. In summary then, the ROPU system is presented as a fast-track, low-cost approach to marginal field development. In addition, the system has the potential to unlock the successful development of fields which had previously been considered submarginal or uneconomic. If you have any questions concerning the technical or financial aspects of the GPS system, please do talk to our staff. GPS, here to help you unlock the future in oil and gas.